How's it going, guys? Matt here with Code Tech Tutorials, bringing you a little video. Now, the video I wanted to bring out this Wednesday wasn't quite ready and still isn't. I'll bring it out when I can, but it turns out some of this coding stuff is hard, so I'm doing sort of a filler episode just to get something for you guys this week, especially for you guys that support me and really want to see stuff and let me know through signing up for my stuff like the Patreon and etc. I got to do something for you guys because I really appreciate you. So I'm going to put together this little video here about NVidia, PhysX, and trying to get a player moving correctly with it because it has been mind-numbingly more difficult than I would have expected. But I'm going to show you all the tricks I've learned so far, and hopefully you'll get something out of this, especially if you like doing physics stuff. Maybe some ideas for how to do movement in the future. A little bit of context. This is basically an early iteration, potentially throwaway code that will be refactored for a game I'm working on that hopefully will come out at the end of the year. That's the plan anyway. So let me just show you a few things. All right, this is just some movement code, but I kind of want to just show you first. So I'm going to hit play on this and we're going to launch it to a little demo world here. And this is just a sandbox level, but I can look around with the mouse. I'm in a first person view. I've got some sticks over there falling just as a physics test, just some basic ground, and I've got some borders, just temporary borders, just to have something. Shadow's not configured right, but I don't care right now. I'll mess with that later. So I've got some WASDA movement here, and you can see, you can't really tell that I'm pressing buttons, sure, but you can see that I'm just, hitting them all and doing little circles like you would in a first-person game. But this is physics-based movement here. Essentially, the player is a capsule. I can look around, and when I press forward, it starts giving me some push. Notice how when I do a quick turnaround, momentum still carries me, kind of like we're driving a vehicle or something. And I ramp off those sticks exceptionally hard. But that's kind of the point. We wanted some physics-based movement, but also I don't want it to feel too clunky. If you try to turn too fast when you're moving too fast, yeah, you can't exactly do it depending on your foot traction. So I'm trying to emulate that a little bit. Now, keep in mind again, this isn't final. This is just temporary, but as you can see, these nice kind of gradual turning curves it makes when I turn is kind of cool. You can maybe 360 no scope, you can face any direction, but as you press forward, it tries to correct to that direction. However, there is a trick to this. Whenever I stop moving, rather than keep it on gliding, it immediately stops. When we stop pressing the movement keys, we stop. So there's probably some tricks to turn around super quick, like rather than having to glide a turn, you stop for a second, spin. So, people that play this for a long time, if I kept the same movement system, would just do that. If they needed to turn, they'd stop, spin. Or you could try it this way, where you just spin the cam and let it keep going and kind of get that U parabola feel, and also get jump in the mix. And you can jump too, and it pushes you up. The jump's not quite right yet, but if you're moving and you jump, it's really hard to tell. So that's kind of a weird thing I've been trying to figure out. Like, I don't know what I need to do to correct that. If I'm just standing there, it kind of jumps okay. All right, so what all set up here, you might ask? Let's take it from the top. We're working with PhysX 4.1. And the reason we're working with PhysX 4.1 is because that is what my package manager supports right now. And that is the one that is battle tested and actually used in development. I know PhysX 5 is out and they recommend using it, but until my package manager has confirmed it and has it stable there, I'm not gonna do that. So we're gonna stick with 4.1.2. So that's the first thing. If you're comparing with some other different version of PhysX, your results may vary. I have no idea. So PhysX is initialize. NVIDIA PhysX has a couple different ways they do this. Now, if you Google search this and try to figure out how the best way to implement character movement, they basically tell you you want a player controller class, PX player controller. And if you just do a Google search for it with this version, you'll find some documentation on the character controller. But the whole problem here with these character controllers, I read through all this, I implemented it, took all the time to get all this stuff set up, and then I found out that this is not what you expect. And half the stuff they have here doesn't even work because, I don't know, welcome to coding documentation. Hey, you new to coding? The documentation is never right. Get used to it. Getting all this stuff set up, finding out that half of it isn't even in the API, and it's just like, it was a real pain. Big problem with this is it doesn't really interact with physics entirely, and I wanted a player that did. This is basically made for cameras that can go through stuff and that clip through walls and clip through all the physics. That's what like these are for. You want a camera that follows people around and doesn't care about collision, then this is what you want. But if you want like an actual thing in the world that interacts with physics, you can't really use this, at least as far as I could tell. What you actually want is just a standard dynamic physics collider. The player controller is not what I want for my player controller. We want to move the player with physics. So we have an initialization function. Let me see. Yeah, here it is. And essentially what we're going to do is, well, I'm calling it player controller, but if you go look at what this is, my player controller is a rigid dynamic. All right, I've type defed a rigid dynamic to just a controller and this player namespace. So I have a player controller and it's a rigid dynamic because that's essentially what we're using to push around our character. It's all going to be physics-based movement and pushing around. That's going to make the game a lot cooler. Yeah, just a rigid dynamic here. So create a capsule. This function is from their boilerplate code. I modified it a little bit to take a material. So we can give it static friction, dynamic friction, or restitution of a set amount because you probably don't want all your players to glide and behave the same. These were tricky to figure out the right numbers, but I feel like these were pretty good. A 0.5 on the static friction, a 0.8 on the dynamic, and 0 on restitution. I wouldn't necessarily recommend those. You got to play around with these numbers a lot. If you don't know what all those terms mean for physics, highly recommend Googling them. Yeah, I'm going to butcher it if I try to tell you, but I would recommend looking up static friction, dynamic friction, and restitution with physics and just observe those definitions because that's how you need to know to set these. So, and then I just put the player where we want to make a rotation with a PhysX quad. I make a transform. This is based on our player location and then a rotation. So we're just kind of setting it in an initial place there. And then we set our controller with these rotation and transforms, this set global pose. And now here's the important settings. If you don't want your capsule to tip over, you have to set rigid dynamic lock flags. So I set one on Z and X, and that's why our capsule never falls over, is because it literally can't lean those directions. We've got lock flags. So if you ever wanted your capsule to lean, you would have to unlock it temporarily, lean it, and then lean back and lock it again. Because normally when I'm doing all this moving around on this game, it would like push it around and it would roll and tumble and not stay straight up. But since it's locked, then it stays straight up and we can get the simulated effect of a standing human, for example. Or, this probably could be translated to be a car or a bike or something, maybe this is even more suited to that. But I was trying to make a guy running type scenario. All right, so we got those locked. Max linear velocity. This determines the maximum speed that this entity can go. And I've got a default walk speed defined. You don't see it here, but I think it's currently like 100 and some or something. So that's what makes sure we don't zoom too fast and we get set to a max speed. Set player mass. This is basically how heavy that object is. Now mass combines with the size. So the size of this capsule along with its mass will determine how much. Of course, there's calculations with these frictions as well. So there's a lot of things involved here. Basically, a lot of it will get dampened out due to its mass and its size and these frictions. So you really got to play around with these numbers to get it right. Add force is typically what we use when we want to move. And because we have these locks and these max velocities, adding forces can only do so much. And we're doing them as a single impulse at a time. So we can keep adding forces until we hit these max speeds if we want. And then, we're kind of at our max speed and it's all's gravy. But right away here, even in the initialization, I add a force. -1 on the Y, that's down in our case. So we add a force down and I'm just multiplying it by the scale just to make sure it's big enough. And this is basically to make our character fall into place so they're not sitting there floating in the air, potentially, depending on what land they're spawning above. So right on a knit, we just give them a little shove down. And that's something that we're going to come back to quite a bit in this, is the shove down effect. Now, why is this so important? Well, because, the Wile E. Coyote cartoon where the coyote would run off a cliff and he wouldn't actually start falling till he stopped and then looked down and realized there was no land. But, realistically, he would start falling right away. But, we got to avoid that. All right, so that's the init. Let's look at these systems. So these happen more when the game's actually running. We got a check cursor look. This just determines your mouse stuff. We're not going to worry about that code too much. But basically, there's a quick version of it if you want to see it. We got to check move keys. Now this sets our movement struct. As you can see, we got all these player movement, dot forward, dot backwards. There's a whole struct, and it gets updated anytime you press one of the movement keys. Basically, every single frame after these are processed, they are set back to false. That's the way I decided to design it. You could also go like it, well, else, player movement, false, etc. And that way you could just keep it on until they are not pressing it. I chose not to go with this method because I had a different idea in mind. So after it processes your latest move, it's going to reset it somewhere else. So that's just done elsewhere is the point. Now here's the run. This is a bit janky. I need to do something better here. Whenever you press left shift, it's going to set your max linear velocity, this is your maximum speed, to a new variable called max player speed. All right, so here's the reset movement. This is like a helper function. This just sets all that stuff to false. It's called at the end of apply move forces. We got process events. This is separate from the physics. It might eventually be part of the physics, but right now, this is for like picking up items and taking damage and stuff. Apply move forces. So this is called once per frame. And this is what basically pushes the character around. So there are maybe some oversights here, as in maybe I should be passing in delta time. Actually, now that I think about it, I'm not sure why I'm not, but it's no matter. We're going to talk about it anyway, because basically I'm just applying direct forces and they're based on the player mass scale. So if we ever want to just adjust the player mass scale, it's going to adjust these forces as well, which could be quite relevant. So we're kind of looking for magic numbers in some of these slots. But okay, let's talk about this. This is the big one. This is the big daddy of moving everything around. We take in a camera reference. Now, why do we do this? Because we want the forward direction. We want to know where the camera is looking. This is specifically the player cam. So maybe I should even say that. This is the player's look camera. So wherever they're looking, that's what direction we want to apply our new forces. I don't know why I don't have delta time in here, to be honest. So I'll sort that out in a later update. Like I said, this is all throwaway, kind of getting started code for now. It's just so I can have a movement system that kind of works. And it kind of works. You can get around a world with objects and stuff. We have some static variables. Why static, you might ask? The short answer is we don't want to reinstantiate these every time we call apply move forces. We just want them to stay here and do what they do. These could be refactored out. So we got to move forced. This is basically to check if we were forced left, right, forward, back. If you press one of the WASD keys, you are doing a move force, and that's what this is. So we'll get to that. We want to know if the move was forced, because if not, we have kind of a different flow we go into later. All right, we also have a timer called the anti-glide timer. This is for when you stop moving, basically. There's a little small amount of time that goes by before it just freezes you in place, so that you don't just keep gliding forever. When you stop moving, you should be able to plant your feet in place. Let's see, I'm holding shift and running. If I just keep it held down and move, I gotta kind of make these parabola type shapes unless I bounce off a wall. Bouncy. But if I just let go of everything, it stops me. And that's what the anti-glide timer does, is it stops you in place. I'll show it more later, but that's what its intention is. All right, so if you move forward or backwards, we get the camera direction, and we apply a force in that direction that you're moving. If you're moving left or right, we also apply a force to the left or right. And as you can see, these directions go off the cameras, get front, get right. So that's how we're getting them calculated. Add force with an impulse. Try to make it powerful enough to seem legit. That seemed to be about the right calculation. Once we get delta time in here, things might change again. But that's it. We set move force to true on both of these. So then if the move was forced on this frame, we go ahead and accumulate up this anti-glide timer. And then as long as it's been at least 1 second of this anti-glide timer, we do a push down. And now this push down basically stops slow gliding, and it also actually makes you properly fall off cliffs. So this actually might be a little long, because you could, in theory, if you timed it just right, run off a cliff for a full second. So maybe this would be better as like a 0.5 every half a second. Maybe we do it 4 times a frame, which is an awful lot, I guess, but we just have to test and see. What happens if, when move forced, we do a push down every, it still feels fine, but I'm willing to bet that if I fell off a cliff now, or walked off a PhysX something, there's nothing to walk off of here really, but it should push me down a little quicker, and it makes it really hard to walk over things because I'm constantly being shoved down into them. Also, it does nice things like I can totally ramp this. Like I can just go boom and ramp super high. There's no getting over these walls. This collider for these walls goes up and down indefinitely, so there's no getting out of this square. So when you set up a level, you definitely can't run off the world. That's just like that by default. We should probably just put in the actual number. I don't know. It's about a 0.6. Let's go with that. It's close enough. It's about every 4 frames. So every time it pushes you down, it resets the timer. So it basically just accumulates up, resets the timer, pushes you down. Now, there's another thing here. There's a player jumped airborne setting. We want to see if the player jumped. We'll mess with that more later. But if the player did not jump and they're not moving in any direction, we want to set their speed to 0. So if the move was forced, but they're not moving, we're going to stop them in place basically. So basically, if you're not jumping and you stop moving, you should get locked in place. But also you might get a quick push down before getting locked in place. I'm not sure if this is logically the best here, but it seems to work. And this is what creates that stop effect. I think I might want this in the anti-glide timer, actually. Like just as a whole nother if, before the reset. Yeah, I think I want this like this. That way we don't do this every time a move is forced, but specifically only when a move is forced and they're no longer moving. Because this first part should trigger even if you're running. This part should only trigger if you've stopped moving, but you still might want this push down effect. I don't know. There's a lot of stuff to play around with like that, but we can give this a quick run with that modified into this anti-glide timer. I think that'll work fine. This should help with the whole ramping effect, because we don't want to ramp and float forever. Like you can kind of do off of these. You're just basically ramming a capsule into some little squares and it pops you into the air. The anti-glide thing seems to be pretty solid overall. So I think it's kind of good enough for now. Yeah, good enough. So there, that's fine. We'll move on. Next up, still the same function. We've got some jump stuff, and it's definitely a hack. First of all, if you jump, we're going to reset the timer. We're going to push you up into the air pretty hard. Mass scale times 20 times the 1. It's going to be pretty hard to push up, but it won't feel like that much, even though it is. All right. And then if the player is airborne when you're going through this, and this could happen multiple times because this only triggers once, and that's, when they press jump and they're not in the air. This is going to trigger as long as they're in the air, so this could continue to trigger. We're going to declare a time in air static variable. So this is basically for an accumulator, and accumulate it based on the jump timer.tick, so how much time has passed since this reset. Up here, push down once. We don't want it to keep shoving you down after a jump, so we want each push down to just be once, and as long as the time in air is greater than the jump cooldown, then it should shove you down. So it's about 0.5 seconds. You'll go upward for about half a second, and then you'll be shoved down pretty hard. That tends to be how it goes here with the jumps. Okay, so if you don't do this push down thing suddenly, you get this very floaty parabola type jump. So that's why I ended up doing this push down effect rather than letting gravity take its course. Gravity will take its course, but if you happen to stop in the air, you sit in the air and just float there, which I couldn't figure out for the life of me. Maybe something to do with the restitution, but even adjusting it, I couldn't get it to feel right. So I ended up going with this push down effect. So here I'm going to jump, a little jump. And then you can see the push down after about half second happen. It just feels very floaty without that shove down. And even with the shove down, it feels pretty floaty. But if the static jump seems somewhat okay. Now I could just say, look, we're not jumping high enough. Let's just boost this into oblivion. All right, 80x. Let's see how high we jump. We'll still get shoved down after 5 seconds, but here we go. Boom. And now we're still going up. The shove down was not hard enough to counteract. And now you can see we're just floating in the air, not moving. Now that's what I want to avoid. So we need to make this shove down harder than the shove up. So maybe we got 100 exit here. Otherwise it's just going to kind of slow us. So this jump, there's no way this is the best way to do it. This is just what I figured out. So hard jump, shove down. That's not too bad right there. Still feels a little floaty, but at least we can get a run and jump going on, unlike before. So maybe I'll leave those numbers there for now. It just seems a bit excessive. Like we're adding an awful lot of force to do a little thing. All right, that's kind of janky, but it's all hack. and then time and error, reset that back to 0 on this. So this is kind of like we've considered being landed, but it's a hack. And then we reset all the movement keys. This is just all the buttons you were pressing. It resets those. But if you're holding it down, they're going to set back to true before the next reset of this anyway. So if you're holding them down, they're still going to be true for the next iteration of this. Last things we do, just update a few positions. We update our camera position to our rigid body position, but we can plus up a little bit on the Y to make it look like the camera is near where your head would be. So this just sets the position of the camera to where we now are. And this shift, pitch, and yaw just sets if you move your mouse, basically. The player entity has a world pause that is not the character pause. It's just its own world pause. So we want to update that too. Don't actually use this yet, but the game will eventually use these. So that's why I'm going ahead and putting it in there for now. So that's the whole apply movement system, the whole first person movement system with NVIDIA PhysX. And that's where my buggy janky code is right now, and it's kind of good enough, as you saw. But I hope you enjoyed this video. Special thanks to my patrons for helping me make it. If you want to support this kind of stuff, you know, there's a like button and all that. I don't want to get into all that, but I do want to say that very specifically I am continuing this nice making videos trend thanks to my supporters on Patreon.